My name is Lane Kessler and I'm a senior at the University of Vermont and I'm studying mechanical engineering. I'm from Burlington, Vermont, and I've grown up here spending time on the lake and around New England, and I love to surf.
You just drop in, just ride the barrel and get pitted, so pitted.
So several years ago I learned about Renown, a company that has taken a non-Newtonian polymer and incorporated it into the core of their all-mountain ski. This allows their ski to dampen and absorb vibrations much more efficiently than any other ski. This idea applies directly to surfboards and lots of other types of watercraft where they have to absorb surface, shock, and vibration. So I had the idea to propose this to the engineering department here at the University of Vermont and have now had the opportunity for the last year to work on this project with 3 other guys.
Hi, I'm Fritz Finkenauer. I'm a senior mechanical engineer at the University of Vermont. Surfing, especially on bigger and bigger waves, can be an incredibly dangerous sport. And so what we're hoping to do is, by mitigating vibrations within the board, we're going to give the rider more control, leading to a more enjoyable and safer ride. By reducing vibrations in the board, we hope that internal stresses will also be reduced, allowing for a longer lifespan of the board. The only trade-off we had to make is that with our new construction method, the addition of the non-Newtonian foam does cause a slight increase in the mass of the board. We will be able to offset the increase in mass by using alternative construction methods.
Hi, my name is Dakota Greenblatt and I'm a senior at the University of Vermont studying mechanical engineering. We considered making our test models out of an EPS foam with a wooden stringer or an XPS foam with a carbon fiber stringer. For ease of construction, we went with the XPS foam with a carbon fiber stringer. Our small-scale test models were about 5 feet long and 10 inches wide, and our main design replaced about 10% of the XPS foam with a non-Newtonian polymer. We also chose a design that replaced about 2% of the XPS foam. To compare our test results, we also built multiple models without any of the non-Newtonian polymer. To incorporate this novel material into the board, we routed channels down the bottom of the board and placed the non-Newtonian polymer into the channels.
I'm Daniel Godelman. I'm a senior at the University of Vermont studying mechanical engineering. The objectives for our project were that it would comply with standard methods of construction for surfboards. It would not increase the construction time by too much. The boards would be lightweight, they would dampen vibration, and they would be marketable. We ran a few numerical analyses in order to determine the stresses experienced by the modified boards compared to the standard boards, and found that under bending there was a small increase in stress experienced by the modified boards. The most important test that we performed was our cantilever bending test for vibration, in which we used an accelerometer to find the damping ratios of both the modified and standard boards. Our results indicated that the boards with the 10% non-Newtonian foam exhibited a damping ratio approximately 64% higher than the standard construction boards. We also performed cantilever beam bending for deflection tests, impact tests, and concentrated loading tests. All of the results from these tests met the requirements for our project.
All in all, this method of construction for surfboards works really, really well. The 64% increase that we saw in the dampening ratio of the boards with 10.3% volume of the non-Newtonian foam in the core should only increase with further testing, because we tested at the very low baseline. So the harder we go and the harder we hit it in the test, we expect a much higher increase in the damping ratios. That being said, all the tests that we did looking at the stiffness and the strength of the boards and the fiberglass, nothing appeared to be compromised in any way. Further testing would be required as soon as you put it into actual boards with, the geometry of a true surfboard, just due to the changes in shape and volume. But we expect this to work, and to work really, really well.
All right.
And we would like to say thank you to Professors Novotny, Rand, and Hernandez at the Engineering Department at UVM, to the Environmental Safety Facility at UVM for letting us use their facility on the construction of our boards, and also to Renown for letting us explore and learn more about their construction methods.